Okay, I want to talk about momentum. And momentum is simply defined as the mass of an object times the velocity of an object. And momentum goes by the letter P. It's a lowercase p. The uppercase P means power. Don't get them confused. You'll also see little Greek letter P's or italic P's used for the resistivity, for example, of objects. Momentum is just mass times velocity. So it could be, for example, a 2 kilogram object is moving at 3 meters a second. What is its momentum? Its momentum is 2 times 3, which is 6 kilogram meters per second. Those are the units to use for it. You might also see the term impulse. An impulse is just defined as the change in momentum, delta P. An impulse goes by the letter J, strangely enough. So it's the change in momentum. So imagine this, an object that's 2 kilograms starts at 3 meters per second and ends at 10 meters per second. You want to find the impulse. Usually you're going to have delta P, the change in potential, the change in momentum is, if it's usually m mass times v final minus mass times v initial. And you can actually just simplify it by saying, hey, I'm going to pull the mass out there, so it's v final minus v initial. So let's see, 2 kilograms ends at 10, starts at 3 meters per second. So you end up getting an impulse J is equal to 2 times 7, which equals 14 kilogram meters per second. That's pretty straightforward. You could also get something like this. 2 kilogram object starts at rest at 3 and ends up going in the opposite direction at 10 meters per second. So maybe it's like kicked in the opposite direction. So in that case, you just need to make sure that your total, we could say opposite direction, your total change in momentum, you're going from 3 in one direction to 10 in the other, so your total change in velocity is going to be 13. So negative 13 kilogram meters per second. So 2 times 13 ends up being negative 26 kilogram meters per second would be your impulse. Keep in mind, these are both vectors, but they point sometimes in different directions. Momentum points in the same direction as your velocity. Whatever direction you're moving is the direction of momentum. Impulse, if it's the change momentum, in order to change an object's momentum, you have to change its speed, which means you have to push on it in some way. So impulse points in the same direction as your net force and your acceleration. And of course, if you're balanced and your net force is 0, then you have no impulse, your speed is not changing, and your momentum would be constant. We'll do a couple more examples related to momentum next. And for now, thank you very much for watching.